Hello students, today we shall start with next chapter, that is chapter number 3, machine, and this is video number 6, part 1. So students, first of all, what is machine is? What is machine is? In a very simple language, machine is a thing that is created by people to make work easier. This is the simplest definition of a machine. Once again, machine is a thing that is created by people to make work easier. Another definition of machine is, that is, machine is a mechanical device. Machine is a mechanical device that changes the direction or magnitude of a force. So, machine is a mechanical device that changes the direction or magnitude of a force. For example, you can take an example of machines. The first one is inclined plane. It is used for easy lifting, or a very common example you can give of inclined plane, that is a ramp. Then you take another example, that is wedge. It is used for splitting and separating the things. Like you can give an example of axe, hammer. So these comes in the category of wedge. Now another, that is lever. Lever are used for multiplying force. Multiplying force. There are so many examples of levers. Later on we will discuss it. Then another example of machines, that is pulley. These are used for hosting heavy load. So these are few examples of machines. Now let us move to some technical terms related to machines. Now the next topic is technical technical terms related to a machine. The first term is load. Now load is a resistive force to be overcome by a machine. Or you can also state it like this: load is opposing force to be overcome by a machine. So it is represented with letter L. Now the next is effort. Effort is the force applied on the machine to overcome the load, means resistive force. So it is represented with letter E. So first of all, the first technical term is load, and it is a resistive force to be overcome by a machine. And effort, it is the force applied on the machine to overcome the load. Now the next is mechanical advantage. The third technical term is, which is related with the machine, that is mechanical advantage, and it is written as MA. Now mechanical advantage is the ratio of the load to the effort. Mechanical advantage is the ratio of load to the effort, or you can write it L upon E. Now since it is in ratio, so it does not have any unit. Just note on it: mechanical advantage does not have any unit. It is just a number only. It is just a number. Now let us take few examples of mechanical advantage. If, let us take the first case, let the case number 1. Case number 1, if load is greater than effort. If load is greater than effort, then the mechanical advantage is load upon effort. So for example, let the load is 10 Newton and the effort is 10 Newton. Newton and Newton get cancelled and it is 2. Means the mechanical advantage is greater than 2. So, equal to 2 here in this case. So we can say that if the mechanical advantage is greater than 1, so that type of machines whose mechanical advantage is greater than 1, they acts as a force multiplier. They acts as a force multiplier. Just note on it. If the mechanical advantage of any machine greater than 1, it means that type of machines acts as a force multiplier. Now the next is case number 2. If the load is less than effort. If the load is less than effort, since mechanical advantage is load upon effort, and this is equal to, for example, you can take, in this case, take 5 Newton is the load and the efforts are more. Newton cancel, it is 1 by 2 means 0.5. So that type of machines mechanical advantage is always less than 1, and the machine whose mechanical advantage is less than 1 that are used to obtain gain in speed. Once again, if the load is less than the effort, means the effort applies are more than the load, then the mechanical advantage of that machine is less than 1, and that type of machines are used to obtain gain in speed. Now let us move to the third case. Now the third one is if load is equal to effort. So mechanical advantage, that is equal to load upon effort, and it is 10 Newton. Effort is also 10 Newton. It is get cancelled and it is 1. Means in this case the mechanical advantage is equal to 1. So the machine which has a mechanical advantage equal to 1, that type of machines are used to change the direction of effort applied. So students, so these are the 3 cases. The first case is when the load is greater than effort. So if the load is greater than effort, that type of machines has a mechanical advantage greater than 1 and are used as a force multiplier. And if the load is less than effort, that type of machine has a mechanical advantage less than 1 and used to obtain gain in speed. And if the load is equal to efforts, so that type of machine has a mechanical advantage equal to 1 and that are used to change the direction of the effort applied. Now let us move to the next topic, that is velocity ratio. The next topic is velocity ratio. It was mechanical advantage and it is represent with VR. Now mechanical advantage, now its velocity ratio. Velocity ratio is equal to velocity of efforts upon velocity of load. Once again, velocity ratio is equal to velocity of efforts divided by velocity of load. Now, velocity of efforts, as we know that velocity is equal to displacement upon time. Once again, as we know that velocity is equal to displacement upon time, so velocity of efforts can be written as displacement of efforts divided by time. Now the next is velocity of load. So this is equal to displacement of load divided by time. Now you can put this value in first. So you will get velocity ratio is equal to displacement of efforts divided by time. Then it is again divided by displacement of load upon time. So this is equal to displacement of effort upon time into time upon displacement of load. This and this get cancelled, and this is equal to displacement of efforts divided by displacement of load. So velocity ratio is equal to displacement of efforts upon displacement of load. Now once again, since the velocity ratio is also the ratio of two similar quantities, so it has no unit like mechanical advantage. It has no unit. Now move to the next topic. The topic is function and uses of machine. Now the first function of the machine, that is it is used or acts as a force multiplier. Force multiplier, or you can write here lifting heavy load, lifting heavy load by applying less efforts. So the first function of the machine is it acts as a force multiplier, like lifting heavy load by applying less efforts. Now for example, jack spade and pulleys. So these are used for lifting heavy load by applying less efforts. Now the second one is for obtaining gain in speed, means increase the distance and speed. Increase the distance and speed. Like you can give example of scissors, knife, etc. Now the third function is transfer transfer efforts from one place to another, from one place to another place. For this you can take an example of paddling of bicycle. Paddling of a bicycle. Now another example of that is change the direction of a force. Change the direction of a force. You can take an example of pulley while taking or while fetching the water from the well. While fetching the water from the well with the help of pulley. With the help of pulley. So these are the four function and uses of the machine. The first function is the machine acts as a force multiplier. Means in this case the load is heavy and the effort applies are less, and that is an example of jack, spat and pulleys. Then for obtaining gain in speed, so in this case increase the distance and speed. Distance also increases along with the speed. You can take off case of scissor while cutting the cloth. You might have seen that the length of the cloth and the speed of the scissor. And then the third case is transfer a force from one place to another. That is a paddling of a bicycles. Then the third case is change the direction of a force while fetching the water from the well with the help of pulleys. Now the next term is, that is term fifth, work input. The next term is work input. So work input, the work done on the machine by the effort. The work one input is work done on the machine by the effort. That is work input. Then the next is work output. It is work done by the machine on load. Once again, what is work input? Work input is the work done on the machine by the effort, and whereas the work output is concerned, it is the work done by the machine on load. Now the next is efficiency. This is the seventh technical point. It is efficiency, it is represent with letter eta. It is represent with letter eta. Now, so efficiency is equal to work output divided by work input. So efficiency is equal to work output upon work input. Again, it has no unit. It has no unit since it is in ratio. So it has no units. So in the next video, we will do relationship between efficiency, mechanical advantage and velocity ratio.